Okay. What do you say we get rolling? Thank you guys for joining me. I know it's late, it's 6:30. It's kind of weird being like the dinner time entertainment. I'm here every day at 6:30 and 10:30. Try the veal, tip your server. We're going to talk about IoT. We're going to talk about maker stuff with IoT. I've got a massive array of demos. If you came and saw like the fervent preparation for all these things, hopefully it all lands. There's an amazing quantity of wires and boards and blinky things and demos, and I'm really excited to be able to share this stuff. It's kind of the culmination of a couple years of work from our team. A lot of people here on site back in Redmond have been helping kind of get a lot of this stuff ready. So without further ado, let's march forward. I'd like to start just by kind of contextualizing this whole hardware thing. How many of you guys kind of grew up as hardware people? Let me just, yeah, so a good chunk of the crowd, and the rest, I assume, software people? Okay, there's a bunch of people that didn't raise hands, so like farming, painting, something like that. I was assuming kind of a mix between hardware and software. So I grew up as a software guy, so I like to contextualize where we are in this exciting hardware space back with my experiences in software. And what I found is there were a few interesting trends that drove people to do all this cool software stuff that kind of exploded in app stores and application development. The first thing is development got really easy. It used to be that to be a software developer, maybe when I was a kid, you had to be this ninja that really understood the finer details of how machines worked, and you were able to code in C and assembly, and it was just a high bar. And today it's very simple to write software. Modern tools are awesome. The second major trend that has really affected applications is there's a ready market to go use those applications, and primarily driven by the mobile phone. The mobile smartphone has the fact that almost everybody, particularly here in North America, everybody's got one of these. So you've got these sockets that are ready to sell into, and people want to buy these applications because, let's face it, sometimes you're waiting for a bus, and Candy Crush is a way to kill some time. The third one is low friction distribution. That not only is there kind of a ready market, but as a software developer through app stores, that market is completely and very frictionlessly available to me. I can pay a fee to a platform vendor usually, and in exchange for that fee I can get my software out to anybody who wants it. And then finally, there's this opportunity that I think is a little bit, was latent, and then we recognized it as an industry for enduring relationships. It used to be that when you bought software, it was kind of a release over release activity to buy a software license. I would go in, buy a piece of software, and then when vNext came out, I would have another conversation with the vendor and maybe buy that too. And instead, it's really changed up such that vendors want to build relationships with their customers, not just to sell version over version, but in-game purchases of content, or to be able to do things like, hey, I'm wearing my Microsoft Band, and this provides me sort of ongoing engagement through some of the analytics that it provides about my level of physical activity. It's those kinds of things that have provided continuous engagement. And so the way I think about it, I think things are just the new apps. And the reason why we get kind of pumped up about this is we're replaying these same trends in the hardware space. Guess what? Hardware development's become really easy. Thanks to Raspberry Pi, thanks to Arduino in particular, tools like that, they're modular. It's like, as a software developer, I grew up doing modular development, putting things in, first structuring them in functions and trying not to make too much spaghetti, and then I graduated to classes and things like that. Hardware's kind of the same way. I can take a baseboard, I can put shields on it, I can attach lures to it, and it's very modular, and all these modules are designed to work independently and be aggregated into one solution. Very easy to do, and the software tools to build those things are also very easy to use. There's become a ready market and an accessible market if I look at things like being able to go and sponsor purchasing some particular piece of hardware that somebody's building, like on Kickstarter. And it's easy for me to get there, and IoT is not a scary thing for people to buy. If you look at home automation as one space as an example, people aren't afraid of going and acquiring that stuff. They're ready to go do it. They're ready to bring these things into their homes. Now, the challenge for all of us in the room, I think we've won when every new device that somebody acquires makes their world incrementally richer. Today, and I do this to myself, every new device I acquire makes my life sometimes a little more complicated. A little more fun and totally awesome, and don't get me wrong, I'm totally cool with it, but it gets a little more complicated. And I think crossing the chasm for us means making it simpler for people. Things like Kickstarter, as I mentioned, make distribution super simple to get my product out there to market. I don't have to go do some deal with major retailers and people who have eyes of customers. Like, I can get directly to those customers. And like software, the sale of my hardware gives me the opportunity to create an enduring relationship with my customer through the data that my device generates, typically, or through the way I want my device to interoperate with other devices that might be in the neighborhood. So those are kind of the trends. I thought I'd just go into a little bit about, this Raspberry Pi board in particular, and I have a few up here. Some of the things I'll be talking about GPIO quite a bit, but you'll hear these terms, and I just kind of wanted to give you the brief primer. So if you think about SPI as a technology that I can use to drive hardware, it's a protocol that you might think of like PCI Express. It's higher speed, and there are fewer of those pins available on a particular board usually than there are I2C pins, which are lower speed, more available. I2C as a protocol is actually a little bit more complicated, but those are kind of how I will drive hardware. And GPIO is kind of like DIY. It's like RS-232 serial port kind of stuff. I can just do whatever I want to do over GPIO, and a lot of the demos I'll show today, I'll show using GPIO, because it's kind of the simplest thing to do. So now let's drill into this Raspberry Pi board. I've got all these pins that you see along the right side of the screen. And if you look at the labels, you'll see that there's a chunk that are power, there's a chunk that are SPI or GPIO, and you can tell by the color the SPI is in pink, and the GPIO is in orange, and the power is in yellow. Actually, the 3.3 volt power is in yellow, and the 5 volt power is in red. And just kind of going through this, I could see, okay, now I'm getting it. I can kind of connect things to these pins, and then I can drive these pins, and I can make some hardware. This Raspberry Pi 2 board, which I'm showing in some of my demos, has a number of other interesting things about it, too. I can attach a display to it. I can go from that display port, or I can go from HDMI. I can attach a camera adapter to it. It supports a network card that I can connect to. It's got 4 USB ports. And it's got, underneath where it says display, it's got a space for an SD slot. So I can put in an SD card, and on that SD card, I can put an operating system that I want to choose to boot. So that's Raspberry Pi. One of the other things I'll hit on in this session is I'll talk a little bit about Arduino, and this is Arduino Uno, probably the most popular model of Arduino. And you can see some analogs, pins for power, pins for GPIO, pins for analog. If I want to drive things, I can connect it to power, I can connect it to the network. Sometimes people ask, well, what's the difference between Raspberry Pi and Arduino? Why would I use one over the other? And the short answer is that Raspberry Pi you can think of as a small computer that has some I/O capability. It's got all those pins that I just showed you, and so it works really well that way. Arduino is really optimized to work directly with the hardware. So there is no operating system intermediating between the software, which they call a sketch, the software you write that runs on that hardware, and the hardware itself, like you're talking directly to the hardware. And Arduino typically has the ability to drive a little bit more power through the pins, so you can often drive beefier hardware through an Arduino than you might be able to through a Raspberry Pi. On the other hand, Raspberry Pi has a microprocessor instead of a microcontroller, so I can write apps, and I can do algorithms, and I can do lots of cool and interesting things using a computer that I might not be able to do using a microcontroller. And I'll talk about in a little bit how to mix these two worlds, because we think we've hit upon some interesting kind of what we would call internally the big brain, little brain. I want a little brain to drive my hardware, and I want a big brain to drive my software and algorithms. So let's start with a quick demo. Let me first introduce you to this piece of hardware. Let me ask as I'm doing this, how many of you have had the opportunity to go visit the little hands-on area with some of the Raspberry Pi stuff? Yeah, that's awesome, a good chunk of people. And I'll make sure, let's see, Elmo's number 4. My first audio-visual test. Let's see if I'm successful. I am, except for the blurriness. There we go. So I'm looking at this board right here. This is the board that I'm using, and I've got this little breadboard attached. Pay no attention to this circus-looking blinky thing that's over here. That that is something that we'll play with later. So this is a Raspberry Pi. It looks very much like the thing we just saw. I've got a couple pins connected to this Raspberry Pi, as you can see right here, driving power and ground. I've got an LED connected to this breadboard, and I've got a little resistor so that I don't blow up my LED. And what I want to do with this demo is simply blink this LED on and off. And so I thought I'd just kind of walk you through the software that I would write to do that. All right, so far I'm 2 for 2 on the AV switches, so I'm feeling really good about this. This is harder than it looks sometimes. All right, so just kind of brief intro, what I'm going to do here is I'm going to set up, this, by the way, is just a universal app. It's just a Windows app. This isn't some special, crazy, like Raspberry Pi flavor Windows app. This literally is a Windows app. I'm using the GPIO support that is part of the Universal Windows platform. If I'm trying to run this application on a system that doesn't have GPIO, it will just fail gracefully. There's some error checks in there that will enable it to just kind of fail gracefully. But this app will run. Like, it will load and run if I were to compile and run this app on my laptop or on my phone. So just to be clear, this is just a universal Windows app. I just set up a little timer because I want to be able to time when I'm the frequency of the flashing of my LED. And then the interesting code here, I can walk through it in order. Interesting code here initializes GPIO. Just a few lines of code. GPIO controller .get default. Now, where does this GPIO controller thing come from? If I were to look at the tooltip over this, windows.devices.gpio. So this is one of our namespaces. This is a Windows namespace. So this is built right into the platform, and I'm able to use it. I'm able to get it. There's only one controller, so get default's going to work. There's a couple error checks here, and then I can open the pin, make sure that the pin is initialized properly, and then I can write a value to that pin. I can write to that pin to get it to turn the LED on. I'm using a little identifier here, LED pin, which is simply the number of the GPIO pin that I'm connected to. If I were to scroll down and show you what that identifier is, it's just 5. So on that map that I showed you that showed all the pins, if you were to count in that map, you would find GPIO pin 5, which is actually something like pin number 28 on the board. It gets interesting to map sort of physical to virtual pins. Couple more things. Every time the timer ticks, I flip the LED on or off. So flipping the LED is just the exercise of writing on or off to that pin and changing the user interface to switch on and off. So I've actually written a little user interface here. Well, apparently it doesn't like the interface that I've written here. Let me try and bring that up again. Guess not. It'll run, right? You would think. We'll give it a whirl. It just did. OK, so let me do this. Let me start running this on the remote machine. By the way, notice although I'm on a Surface 3 as my dev machine, but my debug target is set to remote machine. My remote machine is this Raspberry Pi up here on the table that you were just looking at. And if I were to go to debug, Blinky properties, and I can show you the IP address. So this is just the IP address up here of this board. I'm able to debug to it just like I would debug to any Windows system. So there's nothing really special I have to do to be able to do that. If you're using our image for, I guess there's no other image to use for the Raspberry Pi. So when you use our Windows image for the Raspberry Pi, the remote debugger is already set up for you to go ahead and use, so you don't have to do any kind of configuration for remote debugging. It's already there, already ready. Let me go ahead and run this. And so you should see the output cooking. And meanwhile, let me see if I can switch over inputs. And there you go. So that's what you're seeing now up on the screen is the output of the HDMI of my Raspberry Pi. So that is a universal Windows application running. The blinking is coinciding with the blinking that I have here on my screen, which I can switch over and show you. Sorry, I don't have like cool side-by-side or picture-in-picture or anything like that, so you have to just kind of imagine what that might look like if you close your eyes really tightly and imagine them side by side. There you go. So that's Blinky. That's kind of the canonical hello world of the hardware world. Thank you. Now, another interesting thing I find about hardware, and one of the other reasons, this is Steve's theory of how the world works. This isn't like science or anything, or maybe it is, I don't know, depending on if I'm science. But this is just my theory on how the world works. We use a lot of touch screens, especially in our line of work. Like we're always, touching our computers, touching our phones. That's just kind of how we do things. Those of you that have kids that are maybe less than 18 years old will find that the first thing they do when they go up to a screen is touch it. What did we do? It was like, mom would yell at you, like, I'm going to have to Windex that again. Don't touch the screen. But people have learned to manipulate physically, which is interesting. But what I think is that touchscreens they're a mirage of the real world. They're not really the real world. In fact, I think humans actually prefer tactile experiences. They prefer to touch actual things, not two-dimensional representations of three-dimensional things. And it's my belief that this is also one of the drivers of what's happening in the maker space today and in the hardware space today, is giving humans the opportunity to physically manipulate their world, never mind that those physical controls are just connected to bits and bytes, just like if they were being painted on a two-dimensional screen. It's the fact that we can engage with these in a visceral, physical way makes it more pleasing for us as human beings. And just some examples of some of these kinds of switching experiences that we like to touch. So what we want to offer is a couple things. One is this Windows 10 edition IoT Core that was released yesterday. And combined with Visual Studio, and I've shown you both of those so far already today, to be able to bring that into your world of making stuff. And I hope the way you receive this isn't that we're here to say use our stuff instead of some other stuff. I think what I'd like you to walk away with is try out our stuff too. Try out Windows and try out Visual Studio as well, and kind of add it to your arsenal of tools that you might use to go make things. I think there's still an absolute role to play for other operating systems in this space, for other tools in this space, for other hardware in this space. It's an enormous space. And we've found some opportunities, and I hope you'll agree by the time we get to the end of this presentation to do cool stuff with the platform. But it's additive. It's not instead of. So many of you have seen these robots. I've got one of these robots right here. And I can even show you these robots on the overhead. And then I've got to move all my blinky lights and everything. Let me see if I can get this guy over. The robot's a bit of a challenge because I've managed to tether it in several different ways. And so I am almost certain to break stuff as I go throughout the course of this presentation. So there, I've got one of these robots here. And let's see if I widen the field. There we go. If I widen the field, you can kind of see it. So what the robot is it's a few laser-cut wooden parts. And I've got a Raspberry Pi sitting on top. That Raspberry Pi has an SD card loaded into the front of it. That SD card has Windows 10 IoT Core. I'm connected to the pins on the top of my Raspberry Pi to drive a couple of motors that can drive the wheels forward or backwards. And then I've got kind of some screws and some connectors, a little ball bearing thing there so it kind of runs flat and smooth. I've got a little sensor here so that if it bumps into something on the side, it can stop. It knows that it's bumped into something. So that's essentially what you see here. Cute, cool little robot kit. I've got one that's now up here all plugged in and kind of ready to do something. So what I'm going to do is I'm going to switch back to Visual Studio and show you a project that we're working on to be able to manipulate this robot. I'll tell you, no matter how the demos go, the fact that I'm mastering the AV switching, I'm going to walk away feeling like a winner, honestly. All right, so assuming I have the correct IP address in here, and how do I know if I've got the IP address? We do have a tool that we've made available as a part of the package that you download that's called the Windows IoT Core Watcher. And so this tool, it'll install it along with the other tools. What it does is it looks for Windows IoT core devices on the network. It so happens that I'm sharing the network with a couple devices up here. One's the robot, one was the Blinky device. I've already changed the default password, so anybody that thought about getting cute, wanting to get in and make them do something different, you're going to have to hack my password first. But it tells me what the MAC address is, what the IP address is, and I can do interesting things like I can go to this text robot one, which should be the guy that's sitting up right here in front of me, and I can also open a web browser interface to that device. And we've given you, just for this release, for kind of debugging and purposes of getting familiar with the platform and being able to do some things that are difficult to do otherwise because we're not quite complete yet. You could do some configuration on the device. What app is it running? Can I load or unload apps from the device? Tell me something about what the network situation is on this thing. So just a handy tool that you can use once you've got one of these Windows IoT core devices up and running. So here I am. I'm at the robot app. Let me look around here at the robot app. So a couple interesting things about the robot. One is that, again, it's a universal app. It's a headed universal app, so there's actually some screen output, which is why I have the HDMI connected on this particular robot. And I'm using GPIO to simply drive the wheels one direction or the other. And I won't go through everything, but just to kind of show you some of the code that is used to initialize GPIO pins, and some of the code that is used to actually write a value and then begin the motor to spinning. So what I want to do now is I just want to deploy this application. It's set to deploy the remote machine. Target is ARM. All of that's good. Let's see if this works. That would be lovely. That's never a good sign. Sometimes it's not a disconcerting sign, but it's never a good sign. And while that's doing this, I'm going to look and make sure I've got my IP address right. All right, it says I may not have the right IP address going on. So let's come back to IoT Core Watcher. That's why this thing is handy. Copy the IP address, come back to Visual Studio. Oh, it looks like it changed through. Wow, that's disconcerting. It changed since right before the session when I set it up. I don't know why that is. Maybe that's a bug. Someone in the room might want to file a bug on that. OK, now it says it's starting, deployment starting. And while that's starting, I'm going to switch over now to the output of the robot's HDMI port. And there we go. That's just kind of a little default app screen that the IoT Core produces. Pardon? I can't, let's talk after because it's hard to hear the question up here. So here's the default screen for the application. If it's working correctly, I should be able to kind of use this guy to drive, which is good. Let me see if I can show you back on the Elmo. I'm running over a .NET Micro Framework board right now. I don't mean anything by that. It just happens to be where they're positioned. OK, so now it's going around. So what's cool is I'm using an Xbox controller to drive this thing. If I had a touch screen or a mouse, those buttons that you saw on the UI, I could use those to manipulate the application as well. But I did not plug in a mouse, and that's not a touch screen, turns out. But I can use just a regular Xbox controller to drive this because this is just a regular, shows up as a regular Windows HID joystick that I can use to manipulate. I didn't really have to write any special code or drivers to handle the Xbox controller. Just plugged it in and kind of defined what forward and back and side to side mean. So that's pretty neat. Let me do this. I'm going to just detach the debugger. So I've detached the debugger, which means I've got the application hopefully still running on this device because I want to get at it in just a minute. So with that application still running, here's what I'd like to do. I'm just going to change the target of this application from ARM to x86. And I'm going to say I want to debug on the local machine instead of on a remote machine. Now, Steve, you're crazy, you might say. That was an application that was meant for a robot, not for a laptop to run on. And you're mistaken, I would say. I'm actually going to run it on my machine. And let me, you weren't looking, were you? You were looking at the other screen. So here we go. Let me show you what I just did. I just changed target to x86 and to debug it locally. So with that, I'm just going to hit the green arrow. And if everything goes well, there it is. So now I've got the same exact application that you saw on the output of the Raspberry Pi robot here on my screen. And if this works appropriately, what I should be able to do is drive it using this other Xbox controller that's actually connected to my laptop. So these robots, what they do when they start up is or the app starts up, is it looks for another application to connect back to. And so it found this instance of this application running on my PC, connect back to it, and now I can, if I switch, see, I messed up switching one time, so now I don't feel like such a winner anymore. Maybe I'll get my mojo back. But if I switch back to the Elmo, now you can see I can drive this thing. So it was pretty interesting running the exact same copy of the application, whether I'm running on this device, whether I'm running on a laptop. And I just kind of changed the control mode. Instead of driving the motors directly, my PC sent a command over the network to the robot to go ahead and spin the motors. All right, we kind of looked at the robot. I want to talk a little bit now about building a thing. So typically when we build a thing, I talked about Arduino, and we can start with an Arduino. They're really inexpensive to be able to build a thing that drives hardware. Start with maybe a $30 Arduino Uno, but if I want to do I want an accelerometer. I want to be able to tell when I'm moving about in three-dimensional space. And so that's about another 30 bucks. And then pardon me, what if I want to do speech recognition? Well, that's kind of hard. So speech recognition is about 50 bucks. You add that, and then you can, one of the neat properties of shields is they're often made to be stackable. And you can stack these things one on top of the other to be able to do things because they sit on buses that can share I/O channels. And then what if I want some kind of touch screen display? Wouldn't that be neat if I could tell where I was in space and time, and I can recognize speech, and I can touch, and that's another. And as you see, as you start to actually stack up in physical space, and then you also start to stack up in economic space, it adds up as you add all of these shields. And then there's a whole bunch of things that you might want to do with one of these devices, right? You might want a camera. You might want to connect to something via Bluetooth. You might want to do SD storage to be able to put stuff on it. You might want to connect to a network via cellular or Wi-Fi. You might need speech to text. You might want to have vibration. There are all these things that you can imagine that small devices tend to do. And there are shields, by the way, that do all of these things that you could buy, and you could stack them, and you could have a really cool-looking device just by stacking all this stuff. But sometimes it can become unwieldy and expensive. And so one of the projects we've been working on is this project we internally call Project Margarita, which is the Universal Windows Platform bridge to the Arduino platform. This was part of our announcement yesterday with Arduino. And it's consistent with the other Universal Windows application bridges that we've made for other platforms. It's the idea of saying, hey, wherever you are, there's an easy way for you to come in and also, in an additive way, leverage the capabilities of Windows, rather than in an instead of way. And one of the ways that we thought about doing this is to say, we're pretty good at building these phones at really high volume. We make a lot of these small phones, and in the US anyway, you can buy, I think this is technically a Lumia 620, but you can find 520s, 530s, 620s, 630s for about $50, usually with no contract. Really inexpensive. And if you think about all the cool things you get inside of a phone, if you think about it not as a phone, but as a maker device, wow, all those things on that list, I get an accelerometer, I get a GPS, I get a big touch screen, I get cellular, I get Wi-Fi, I get Bluetooth. The list kind of goes on and on of all the cool things that I could get if I could find the right ways to connect a phone like this to a device like an Arduino. So I want to start with when I develop applications for my phone, it's cool, but you know what my phone is really bad at? My phone is really bad at driving hardware. Like I could, tape an Arduino to the back of my phone or, push buttons on it or something like that, and that might be one way to do it. It's a bit unwieldy, but that's one way I could do it. One of the things that we announced here at Build is this remote Arduino wiring, or Windows Remote Arduino. Allows me to do something like, from my phone, I can build that app that I could take a picture with my phone camera, and then I can scale it and transform it and do all the things that are storage and computationally intensive and hardware intensive, and then I can maybe send that over to the Arduino to drive some kind of experience. And this idea of remote Arduino is pretty cool. I wanted to show you a couple of demos, actually, of this thing. So let me start here. So now we'll bring this guy on board. So this thing that it kind of looks like Frankenstein's monster, and in addition to turning on its creator, one of the other things that it does is it's just a bunch of wires that are plugged into all the various pins of an Arduino so that I can drive that Arduino remotely. I just want to do this for demo purposes. So what I've got here on my setup is I've got an Arduino Uno. On top of the Arduino Uno is a weather shield that knows how to read temperature and barometric pressure and humidity and that sort of thing. And then I've got, from all the I/O pins, I've got a bunch of things that are driving LEDs, a bunch of wires that are driving LEDs. I've got a little potentiometer here that I can turn. I've got a button that I can press. And then I've got a little Bluetooth shield here that I'm using to be able to connect from this device to the world via Bluetooth. So let's take a look at a couple things here. So I'm going to open up another Visual Studio project. And in this case, screen. I was doing so good, and then I completely fell off the wagon. OK, that's Visual Studio. I saw it. It was here. So this is Visual Studio. And what I'm going to do is this is an app that is intended to run not on this Arduino, but it's intended to run on my phone. And using remote Arduino over Bluetooth, I can use my phone to access and control the capabilities of the Arduino device. And so just a couple things from a code standpoint I wanted to show you guys, just to kind of get a feel for how this thing works. One is in the setup. So you could see in the setup code, I am establishing a Bluetooth serial connection. I am doing this new UWP Fermata thing, creating a Fermata object, which you can see is one of the namespaces that we provide. And same thing for this remote device. And in fact, if I look into this remote device through go to definition, you can see that it's in metadata. And what this remote device is it's kind of an API that is part of the Universal Windows platform that's a representation of the things I can do via an Arduino API. So I can read, I can write, I can get up the I2C bus access. I can do all of these things that I would be able to do, but I've got a nice Universal Windows Platform API set that I can use to do that. Now, I'm kind of passing this Fermata thing. What Fermata is it's a standard protocol for driving microcontrollers. And so I'm just going to use that standard protocol for microcontrollers to drive this particular Arduino to be able to do interesting things with it. A couple other things I would just point out. One is, and let me show you what this application looks like, assuming I don't get any XAML errors on this one. I'm getting XAML errors on this one, so I'll show you on the phone. Let me go ahead and deploy and run this guy. OK, so I'm deploying it now to my phone. So now what you see on the screen is the phone that I'm using right here in my hand, just a picture of the screen. What I'm going to do now is I'm going to connect to the Bluetooth device that's sitting right here, and that happens to be this one, I believe. Good. And so this is the UI that I wasn't able to show you in Visual Studio. But what this is this is just, it looks like the rails on the Arduino. It's just a representation of the different pins on the Arduino. And so when I push buttons on my device here, and you can see I'm pushing a bunch of different buttons, what's actually happening is on the device, I'm lighting up the LEDs. So I'm driving this Arduino from my phone, and I haven't gotten to what's actually running on the Arduino yet. I'll get to that in 1 second. But I can do other things, like I can hit the humidity button on my device, which I'll show you in just 1 moment, and it will read out the value from the weather shield. So when I hit humidity, you can see that it says there's 32% humidity, which is it that dry in here? It didn't feel that dry to me in here. I should be able to, for example, play with the potentiometer, and you can see the numbers spin as I play with the potentiometer, so that's really cool. So the question is, what am I doing on the Arduino to kind of be able to get at it from my Windows device like that? And it turns out that, yes, I would please like to stop debugging. And it turns out that, let me head over to the Arduino IDE. And the Arduino IDE contains a number of examples that are kind of come with Arduino out of the box, including an example called standard Fermata. So there it is. So this is just the stock standard Fermata example that comes from Arduino with their download. This was the sketch that we loaded into the Arduino device. So literally, I was able, from a Windows application using UWP, to drive all the pins and capabilities of this Arduino device. And I never even had to write a line or learn a line of Arduino code. I was able to deploy the standard Fermata sketch, get that running, and then once that's running on the Arduino, kind of the world is my oyster from a Windows application. It's really cool. Now, this is a pretty simple example and a somewhat contrived example to be able to show you all the things that light up. There are more complex things that we could do as well, and that's another thing I'd like to show. So let me, I'm going to open up another example, and Dan, why don't you, this is IoT Dan taking off the, doing the big reveal. Yay. Okay, so this is when you let the team go loose, and you're like, okay, now we want to do this with this remote Arduino thing so that we can really drive some hardware from a Windows device. Other than having some really interesting blinky LEDs, what could we do? And the answer, of course, is a lot more LEDs. And so what you see is a massive screen full of LEDs, and I'm almost certain we're not violating any local fire codes or NECA or IBEW electrical rules. Totally safe. It's on its own circuit. But what we have here is we want to be able to render an image that we can take from this phone. I want to be able to capture an image on this phone using the camera, and then I want to be able to render that image over there to the LEDs using my Arduino to drive the LEDs and using my phone to handle all the processing load of capturing the image and kind of rasterizing the image to this smaller, I think it's, I don't remember how many pixels, 48 by 48 or 40 by 40, I don't even remember, 40 by 40. And if that would work, I think that would be pretty cool. So let me start by trying the application out. And so, by the way, it's worth noting that although Arduinos are good at driving hardware, they're fairly small and modest compute devices. In fact, the array that you would use for this set of pixels does not fit into the RAM of the Arduino. You've got to kind of wrap your mind around that, like, wow, like there's no frame buffer because the frame is bigger than the buffer. So how do you do that? What we do is we do all of that here locally on the Windows phone, and I'm seeing a deployment error. Let me make sure my screen is unlocked here. Doing all of that processing on the Windows phone, and then sending the information sort of bit by bit via blobs, binary blobs, until it paints the entire screen. And it's registering. OK, so now what you see is that application. Now, in this case, we have done a little bit of work to the standard Fermata application that's running on this particular Arduino Shield. So we've made some editing. We did write a little bit of Arduino code to get this one working. Let me try this. Let me see if I could take a selfie here. OK, here we go. Oh, there's a light behind me. It's going to be really hard to do, but we'll see if we can capture my face. There we go. OK, and I'm looking down. That is not my best picture that I've ever taken. And then we're going to tell it to drive the screen. So how many of you went to the session I did on IoT last year? Yeah, I did this thing where I had this traffic light, and I left it on so that like the guy in the front row got sunburned. That was fun when that happened, wasn't it? So let's try this. Let's see if I can take a picture of you guys. Let's see how this ends up. OK, I've taken a picture of you, and we're going to render that. Yeah. It's hard to see. Oh. Just the top of the screen is taken. So yeah, it's I think you're the pixel on the. So anyway, great example of kind of, and let me do this. This is our trick for not sunburning people. Let's see if this kind of works. Is to take a picture of a black screen and then paint it. There we go. All right. There was some trial and error involved in figuring out that solution, believe me. Yeah, so that kind of gives you an idea of the kind of things that you would do if you kind of take this remote wiring to its logical conclusion, really using the power of Arduino to drive hardware, which is what it's best at, but recognizing the fact that it's not good at having a lot of RAM or being able to do image processing, offloading that work, in this case, to my phone. Now, if I were to, I'm just going to stop the debug session here. The code here is just to show you a couple pieces of code that I think are interesting. One is just kind of the same set of code to set up, yes, it's over Bluetooth. Yes, I'm using Fermata once again. So similar pattern to what you saw with my small example here of the blinky LEDs and the potentiometer and that sort of thing. What this thing does is the main work is done by this draw image function, which is what takes the camera image, then kind of knows how to rasterize it based on the kind of image that you want to render to the screen. And once it's done that, it kind of calls this shift bytes function over and over again for every blob of data and just kind of passes it over the Bluetooth channel until it lights up every LED. So pretty cool. Let's see what else we have here. So what we showed was this idea that, hey, without really learning how to be an Arduino programmer, I can use the Windows Phone combined with an Arduino to drive hardware. What we'd also like to talk about is this idea of Windows Virtual Shield for Arduino. Kind of the converse. I can, without learning really how to be a Windows developer, I can, from my Arduino code, leverage all the capabilities from my phone, just as if my phone were a set of shields that I had stacked on top of my Arduino, except in this case, I want to do it over Bluetooth. And so that means things like the screen or things like speech recognition, they could just show up in my Arduino world like a natural thing, the same way that I would show up with this weather shield that I would just put on top of the hardware. So let's take a look at what that might look like. I'm going to go into my Arduino code now. And so here's my Arduino code, which you're going to see in just 1 minute. There it is. So there's my Arduino code using the Arduino IDE. And so looking at the Arduino code, if you're not familiar with Arduino, their sketch language is a C-like language. There's pound includes, there's curly braces, there's function calls. It's got all that kind of stuff. The things I want to point out to you are the includes here. These are includes that are about the virtual shield. So I want to be able to get at the virtual shield support. I want to get at the screen, which is graphics.h. I want to get at the accelerometer for my phone. I want to be able to get at speech recognition for my phone. and I want to be able to get to the web. I want to use my phone as a conduit to the World Wide Web via Bluetooth, or sorry, via cellular or via Wi-Fi, however the phone might happen to be connected. And just to show you a little bit of this Arduino sketch code, what the setup function does, usually there are two functions at least, setup and loop. What the setup function does is it sets up all these shields, and it sets them up in such a way that the action becomes callbacks. So inside of our run function, it just includes a call to like execute on all the callbacks when it's appropriate to do so. So I set up callbacks, and then so I have callbacks for things like, hey, when I get an event for the screen, this tells me, or this is actually the setup event. This tells me, okay, I want to draw some buttons on the screen, and I'm going to look up colors on Wikipedia. Wow, what does that mean? And you see the call to web.get. So what this means is one of the things we wanted to do with this demo is we wanted to use the web to go find all the colors that are in the Crayola color catalog. So you know how Crayola has colors like tangerine and burnt sienna and all these kind of weird things. We thought that would be a fun set of colors to go use. So there's actually a Wikipedia page, of course, where you can go and look at all those colors. So we grabbed that, and then we're going to use those colors as part of the speech recognition so that we can get the appropriate color drawn on our Arduino. And we're just going to draw a point on the Arduino. So the web event, all this thing does is once it gets that response back from the Wikipedia page, it parses it and it says, great, I've got that information, that's awesome. And then we've got this other thing here that draws to the screen based on the speech. So once it figures out, here's the color you wanted, I get the XY coordinates, I draw on the screen the pixel, which is a very big, beefy pixel that you want to see. So let's see if we can get this thing running. What is really, really neat about this particular demo is I literally do not have to learn how to be a Windows developer. All I have to be able to do is run a Windows application. So we've written this application here, which is the Virtual Shield application. It's not yet available in the store, but we've made the source code available. In fact, I think the source code for absolutely everything I'm showing you today, with the exception of maybe one demo, is already on GitHub. You can get it everything. You can try it out yourself, hack around with it, including this application. Eventually, it will be in the store, so you don't even have to know how to go get to, you don't even have to know how to get to GitHub. You just have to know how to go to the store. So I'm going to run this application. And so all the code I've written sits over there on the Arduino. It's looking up the colors on Wikipedia. It's found them, parsed 120 colors. I only have the 64 color package of Crayolas. I didn't really realize there was a 120, but apparently maybe they change over the years, like Baskin-Robbins, only a 31 at a time, but the entire catalog of flavors is actually fairly big. All right, so I've got this guy going. So let me say go. Let's see what happens. Are we drawing? All right, so what should happen? I can't see the screen, so I'm relying on Dan to tell me that things are happening. It's using the accelerometer, so as I tilt the phone, it should be drawing the pixel in different places. So that's pretty good if that's in fact happening. Nobody's booing, so it's probably happening. I feel pretty good about that. Now I'm gonna hit on the phone. I'm gonna hit this color button, and I'm gonna ask it to paint a different color. Cerulean. There we go. Let's try one more. Tangerine. Pine green. Doesn't understand my accent. White. Yeah, that seems to work okay. What about black? So as you can see, the app works fine. Now, one of the things we thought a lot in working on Windows IoT Core is this idea of connectivity. If you attended a session I did with Sam George yesterday, we talked a lot about connectivity for IoT devices. And to me, connectivity is what really represents the difference between embedded and IoT. Embedded devices are small computers embedded in things that exhibit some independent behavior based on having an onboard computer. It becomes IoT when these devices can connect to the other devices around them in their ambient environment and also connect to the cloud. And so we focused on that in a couple different ways. One is you'll find, as we demonstrated yesterday, ready connection up to Azure's IoT infrastructure. So as you're building out devices like this, you have the ability to leverage the data that they generate, gain interesting insights from the data that it generates, be able to view data in real time, be able to find alerts and anomalous behavior in real time. But then also, Gavin Gear gave a session earlier this week about AllJoin. And AllJoin is an investment that we've made in Windows 10 that's available in all Windows 10 editions, including IoT Core, as a local sort of proximal network technology for devices to talk to one another. It's my point of view that devices, they want to be free. They want to talk to other devices. They want to talk to the cloud. And we only win. This is one of those things where we only win when we can light up that world when I add a device, my world gets richer. If you think about it, that world only happens when devices can talk to one another. Otherwise, I'm thinking about, OK, how do I only acquire devices that are in the particular walled garden ecosystem that I may be participating in? Devices should just know how to talk to each other. That should be the default behavior for devices. Now, speaking of which, I'd like to talk a little bit about smaller devices and also talk about how they connect via AllJoin to the world. .NET Micro Framework is a technology that we've worked on for several years, and it represents a smaller class of devices. So those devices that we talked about, Arduinos running on microcontroller class silicon, that is where .NET Micro Framework works best. These days, typically, that's represented by ARM Cortex M3, M4 class silicon. Here are two new boards from one of our partners, Secret Labs. They've got a great product called NetDuino, and it allows me to use Micro Framework, gives me the ability from within C# in a .NET environment to write code that actually runs on these little tiny platforms. And in many ways, or very often, that code that I write for these little platforms will also be upward compatible to larger versions of .NET. So NetDuino 3 Wi-Fi has onboard Wi-Fi, NetDuino 3 Ethernet, onboard Ethernet, and a couple of other partners we've worked with. GHI is another big maker of .NET Micro Framework devices. On the left, you see their GHI Fez Spider Kit, which is taking the idea of Micro Framework and then adding to it modular hardware so that I can plug on cameras and joysticks and lots of different sensors. And then what you see on the right there is a prototype of a hat for a Raspberry Pi 2 that allows me to kind of enjoy that modular hardware ecosystem that GHI has been famous for, and to do that on top of Raspberry Pi 2 on Windows 10, not just on .NET Micro Framework. So that's pretty cool. I did want to show you one demo for .NET Micro Framework. Let me start by showing you this board, which is a monster for a Micro Framework board. We think that big is the new small. And so we've got this board that's like the size of my hand. Like, all of your door locks will be this big in the future, believe me. I'm here to tell you. No, what this is actually a development board for Micro Framework. So typically, if you kind of work in the hardware space, what you'll find is vendors, and this one comes from ARM, vendors will give you these development boards that kind of has the SoC that you want to target, but then it's got all the IOs and all the connectors and all the support for everything that you might want to do with it. And this is one of these. At its heart, it's a Cortex M4 ARM architecture. And what I wanted to show is just a little Windows application here, combined with my television. So what we've done is AllJoin has a small form factor that's designed for the smallest device, like Micro Framework devices. And using that small form factor, I'm able to create AllJoin compatible devices and put them, or create these tiny things and put them in AllJoin, tiny devices that are AllJoin compatible, so that I can have door locks, or I can have light bulbs, or I can have the smallest things that speak AllJoin, not just bigger devices like this Windows machine here. So I'm going to switch to my laptop. And so what should come up here is a .NET Micro Framework project. And so you could see this .NET Micro Framework project. What this does very briefly is just sets up sets up this device as a member of the ambient network's all-join bus. Because it is running the small version of all-join, it looks for a router that it can connect to, that it can allow it to connect to other devices or the outside world. It so happens that that router functionality is built into Windows devices, including a Windows phone that I'm running here. So what it will actually do is it will communicate. I can communicate from this .NET Micro Framework device to this Windows device. They can discover each other. They can shake hands. They can get to know each other. And then once it establishes that connection between my phone and the small Micro Framework device, it can use my phone to route communication to other devices on my network, including this television here, which this LG television also, and this is a commercial that you can probably buy across the street at Target. This particular device speaks all-join. This is a commercial device that you can buy today that speaks all-join. So just to show you a couple pieces of code here, there's just kind of big while true loop that this thing sits in while it's running. And it kind of does some housekeeping first. It makes sure that it gets an IP address set up. It starts up the all-join service and makes sure that the all-join service gets set up. Once the all-join service is set up, it looks for a router, connects itself to that router. And then it kind of sits in a message pump loop, handling messages. And there are a couple of interesting messages for this demo. One is the phone is allowed to read, and the other is the phone or any device in the all-join network is allowed to read or write the value of the temperature. And I've hard-coded the temperature for purposes of this demo at 70. So what I'm going to do is I'm going to run different phone here. It looks the same, but it's actually a different phone. And let's come out here. All right, so I've got this application. It's connected, which means these two devices have already found and connected to one another. What I can do is I can read the temperature from this Micro Framework device, and again, using all-join. Okay, it's got it at 70 degrees. And the other thing that I can do is I can set the temperature. And when I...
temperature is degrees Fahrenheit. The current temperature is degrees Fahrenheit.
Wow, that was like a mix. That was kind of cool. What it will do is when I set it, then it will send an all-join broadcast to say, hey, someone has set my temperature. If all goes well, that all-join broadcast should be picked up by this television here in front. So I'm going to click this Send to TV, which will set it and send this broadcast.
I'm sorry, I could not find the weather station device.
Ooh.
I'm sorry, I could not find the weather station device.
That should be OK. Let me just try and make sure this. Let me rerun the application one time. Let's see. I'm sure it's going to be awesome. It's totally going to work.
I'm sorry, I could not find the weather station device.
There's kind of a finality in the way she says that, isn't there? I'm going to go with what Cortana tells me. All right. And a couple calls to action I have for you. One is if you haven't already, please visit windowsondevices.com. Again, be able to explore source code, figure out how to set up Windows on your Raspberry Pi 2 and Miniboard Max devices. Here at the conference, you can do the Quick Start Challenge. You can do the IoT workshop. So lots of things that you can do to kind of get engaged and start working on stuff now. I do have one last thing as we're up against time. I'm going to give all you guys one of these cool robot kits. Yay. Thank you for coming. The kit has a Raspberry Pi 2. It's got an SD card pre-image with Windows. It's got the robot kit components. It's got sensors, wires, LEDs. I wasn't going to do it, but because the Micro Framework thing failed, I thought I owed you guys. So thank you for coming to build. Enjoy the rest of the show.